All right, so this one's from your book. Two 2-kilogram bodies, A and B, collide. The velocities before the collision are VA equal to 15 I hat plus 30 J hat meters per second, and VB equals negative 10 I hat plus 5 J hat meters per second. After the collision, velocity of A is negative 5 I hat plus 20 J hat meters per second. What are A, the final velocity of B, and B, the change in total kinetic energy, including the sign? So here we have a collision, and it's in 2 dimensions because we have I hat and J hat. That's our X and Y directions. So we need to split this up, and we have conservation of momentum in both the X direction and the Y direction. So first, let's do the X direction. I know in the X direction that momentum is conserved. So that means that the initial momentum in the X direction will equal the final momentum in the X direction. Of course, there are 2 objects here colliding. So we get momentum initial of object A in the X direction plus momentum initial of object B in the X direction is equal to momentum final of A in the X direction plus momentum final of B, not A, B in the X direction. And then, of course, I know momentum is equal to mass times velocity, so I can plug that in now. So MA, V initial AX, plus mass of B times V initial B in the X direction equals mass of A times V final A in the X direction, plus mass of B times V final B in the X direction. Of course, I'm not going to write this for the Y direction as well, but I did want you to see how that third equation is derived. So now I can start plugging in my numbers. So I know the mass of both A and B are both 2 kilograms. So 2 kilograms times the initial velocity of A in the X direction, and that will be this 15 meters per second up there. So I get 15 meters per second plus mass of B, 2 kilograms, times the initial velocity of B in the X direction, which will be that negative 10 meters per second. Oops. Equals mass of A, 2 kilograms, times final velocity of A in the X direction, which will be this negative 5 meters per second, plus mass of B, 2 kilograms, times final velocity of B in the X direction. So starting with that left-hand side, I have the quantity 2 times 15, close parentheses, plus 2 times a negative 10. And so on that left-hand side, I get 10. And then we get equals 2 times a negative 5 is a negative 10 plus 2 times V final B in the X direction. So adding that 10 to both sides, I get 20. And then I divide by 2 in order to get V final B in the X direction by itself. And that ends up being positive 10 meters per second. Now doing the same thing for the Y direction, I have mass, let's do this in a different color. Keep it a little separate. I have mass of A, V initial A in the Y direction, plus mass of B, V initial B in the Y direction, equals mass of A, V final A in the Y direction, plus mass of B, V final B in the Y direction. So momentum is conserved in the Y direction as well. So again, mass of A is 2 kilograms, times initial velocity of A in the Y direction is that 30 meters per second, plus mass of B, 2 kilograms, times initial velocity of B in the Y direction, which is a positive 5 meters per second, equals mass of A, 2 kilograms, times final velocity of A in the Y direction, which was a positive 20 meters per second, plus mass of B, 2 kilograms, times final velocity of B in the Y direction. So again, starting with the left-hand side, I get 2 times 30 plus 2 times positive 5, which is 70 on that left-hand side, equals 2 times 20 is 40, plus 2V final B Y. 70 minus 40 is 30, divided by 2, we get V final B Y is equal to 15 meters per second. So our final velocity of B, so velocity B and then prime is how they used this to denote that that was the final velocity of A. You can also write V final B, whatever you want to do, is equal to our X component of the velocity, which is 10. So 10 I hat, and then plus our Y component, which is 15, 15 J hat meters per second. So there's our answer for the final velocity of B. And then for the second part, letter B, it says, what is the change in total kinetic energy, including the sign? So our change in kinetic energy, and I'm going to erase all that stuff. For part B, change in kinetic energy is equal to kinetic energy final minus kinetic energy initial. Now for this, kinetic energy is just when an object has a velocity. It's 1/2 mass times velocity squared. So our final kinetic energy will actually be kinetic energy of A final plus kinetic energy of B final. And then initial will be kinetic energy of A initial plus kinetic energy of B initial. So plugging in our equation for kinetic energy, our change in kinetic energy will be 1/2 times mass of A times final velocity of A squared plus 1/2 times mass of B times final velocity of B squared. And then minus our initial kinetic energy, which will be 1/2 times mass of A times initial velocity of A squared plus 1/2 times mass of B times initial velocity of B squared. All right, so we know the masses of both A and B, they're both 2 kilograms, but the problem is we know the final and initial velocities of both in unit vector notation. So what we need to do is we need to find the actual velocity vector for the final velocity of A, final velocity of B, initial velocity of A, initial velocity of B. So we need to resolve those vector components in order to get the actual velocity vector from each of them. Show you what I mean. So let's start with initial velocity of A. So the initial velocity of A is going to be the square root of the initial velocity of A in the x direction squared plus initial velocity of A in the y direction squared. So that ends up being 15 squared plus 30 squared, and then we'll take the square root of that. So square root of 15 squared plus 30 squared. And we end up getting 33.54 meters per second for our initial velocity of A. Now we're going to do the same thing for all the rest of the velocities. So let's do initial velocity of B. So that is the square root of -10 squared plus 5 squared. Which ends up being 11.18. For velocity final A, we get square root of -5 squared plus 20 squared. Which is 20.62. And last but not least, we get final velocity of B, which we actually solved, will be square root of 10 squared plus 15 squared. Which is 18.03. All right, now that we have all of our resolved velocity vectors, we can then plug it into our change in kinetic energy equation. So we end up getting change in kinetic energy equals our 1/2 mass, 2 kilograms. Final velocity of A was 20.62 squared minus 1/2 times 2 kilograms times final velocity of B, 18.03 squared, minus, oh, and that was a plus in the center, I'm sorry, minus the quantity 1/2 times mass of A, 2 kilograms, times initial velocity of A, 33.54 squared, plus 1/2 times mass of B, 2 times initial velocity of B, which was 11.18 squared. And then plug this all into our calculator. So in the first one, I get 750.2653 minus 1,249.924. So for our change in kinetic energy, we get negative 499.66 joules. And so the sign is a negative, which means that we're losing kinetic energy. So if they asked you whether or not this was a elastic collision, completely elastic collision, the answer to that would be no, because kinetic energy changes, right? We lose some kinetic energy, and we know that in completely elastic collisions, kinetic energy is conserved.